Alright, let's look at some more of these quadratic equations we like to solve. The first one here is actually one that we could factor, like we saw in the other videos. It's just a special kind of way that it factors. We have basically an x and an x, and a 5 and a 5. Signs are the same, they're both positive, and so it's just that x plus 5 quantity squared is 0. Now, the only way that's going to work if x plus 5 is 0. And that's going to be the case when x is negative 5, and that's the only answer. You know, geometrically what's going on behind the scenes is we're trying to find out where these parabolas intersect the x-axis. And so with this particular parabola, it's only going to intersect at negative 5. And so the graph of it would look something like this. At negative 5, we'd have the minimum, and it would look like this. Okay. This next one here doesn't factor. There's no way to multiply to give you 14 and add up to 8. And so when it doesn't factor, it's not over. You can solve by completing the square. You can solve by the quadratic formula. Let me first take a look at the completing the square option for this one, because it seems to work out nice with this one. So we're going to complete the square, and the way that works is we are in search of exploiting the relationship between the 5 that's in this problem and the 10 and the 25. The relationship there we exploit, because this is what we're in search of, having a perfect square. We don't have it right now like we did here, but we can go get it. We can get it by adding something to both sides of the equation. And so we're going to exploit that relationship. We're going to have x squared plus 8x plus something that we add so that we have a perfect square. Now we still have this 14, and it's still equal to 0, and when we add that something, we have to also add it to the other side. And so playing the role of the 8 here is this 10, and we need to work in this direction where we have the 10, and we want to know what goes in here with the x in the perfect square. It's half of that coefficient on x. So half of the 8 is a 4, so what goes in here with the x is a 4. We keep the sign. Now we want to exploit the relationship between the 5 and the 25 to figure out exactly what this constant is that needs to be added. And in this case, it's going to be the square. 5 squared is 25, so 4 squared is 16. So we need to add 16 to both sides. We add 16 to the left-hand side, and we'll add 16 to the right-hand side. And so now we have a complete square, and there's a 14 added to it, and that's supposed to be equal to 16. Let's just subtract the 14 over, and what we have is this complete square is equal to 2. You don't have to multiply this out, that'd be going backwards. You can solve this by taking the square root of both sides. Basically, x plus 4 could be the square root of 2. But x plus 4 could also be this negative, the opposite of the square root of 2. And so when we take the square root, we're going to have x plus 4 being plus or minus root 2. On the one hand, x plus 4 is root 2, so x is negative 4 plus root 2. On the other hand, x plus 4 is negative root 2. So x is negative 4 minus root 2. And those are our two answers. That's solving by completing the square. We could also solve by the quadratic formula, and let's take a look at that one. Not on this problem, but maybe on a different problem. So we could do it on this problem if you like. So ax squared plus bx plus c is equal to 0, and x is negative b plus or minus the square root of b squared minus 4ac all over twice a. So for us, playing a role of b is an 8. So we'd have negative 8 plus or minus the root of 64 minus 4 times 1 times 14. All over 2. That's 56. 14 times 4 is 56. 64, take away 56. 64, take away 56 is an 8. We simplify the root of 8 to be 2 root 2. And then the last step is to divide each of these by 2. Take negative 8 and put it over 2. Take 2 root 2 and put it over 2. And you'd have exactly the same answer, negative 4 plus or minus root 2. So there's the problem solved with the quadratic formula. And here's the problem solved with completing the square. Okay, great. Now down here we have another problem. Let's go with completing the square. It's going to be more complicated though. When you have a constant other than 1 in front of x squared, completing the square becomes more complicated. So what we do is we take this 4x squared minus the 24, minus the 24x, and add a blank space. And that's going to be equal to 9 plus some blank space. Now here we have to take out a 4, and then we're on the level that we were before. We take out a 4 from the left-hand side. And so, by taking out the 4, we'll be left with a negative 6. And then negative 6 is going to play the role that the 8 played and that the 10 played. We're going to have this guy become a perfect square. And what's in there with the x is half of that coefficient. And you keep the sign. So we have x minus 3, quantity squared. Now when we get the blank space, we realize that we have to square the number that's in there with the x. The 4 becomes a 16, the 5 becomes a 25, so the 3 is going to become a 9. But in this problem, there's a new wrinkle because of the 4 that we had to factor out. It really isn't a 9 that we added to both sides. In essence, it is actually a 36 because that 4 needs to be a part of that as well. So we added 36 to both sides, actually. And the 9 plus the 36 is 45. And now we can solve this by dividing by 4 first. And then taking the square root like we did previously. The square root of 45 over 4. So we're going to take the square root now. And we have x minus 3 is equal to plus or minus the square root of 45 over 4. Sorry about that. And so x minus 3 is equal to plus or minus the root of 45 over 2. And we can simplify the root of 45 and write it as 45 is 9 times 5. So the root of 45 is the root of 9 times 5, which is the root of 9 times the root of 5. It's 3 root 5. And then we just add 3 to both sides. And that's our final answer. Plus or minus those Yeah. We could have done this by quadratic formula, but it would have been difficult because of the large numbers there. Without a calculator, it would have been not that easy to do. Okay, I won't do that one also by quadratic formula. On this last one here, I probably would avoid completing the square method. It works really nice when the coefficient on x is even. There's no fractions introduced really. But when the coefficient on x is odd, I tend to avoid it, just to avoid the fractions. So we have x squared plus 3x minus 9 equals 0. We're going to have it set equal to 0. For the quadratic formula, we must have it set equal to 0. And we're going to quickly see it. We're going to get x equals negative 3 plus or minus the square root of b squared, that's a 9, minus 4 times 1 times a negative 9. Be careful, it's a negative 9, which helps out. Because if it wasn't a negative 9, we'd actually end up with a negative number under the root. But because it's a negative 9, it works out, and that's all divided by 2. That's a 36. 9 plus 36. And so, negative 3 plus or minus the square root of 9 plus 36. And that's all over 2. So that's a 45 again. So that's negative 3 plus or minus 3 root 5 all over 2. We can just leave it like that. It's almost the same as the last problem, but not quite.